let's talk about work, and in particular, work that is done by a gravitational force. And maybe we should just take a quick step back and try to shore up our understanding about what work is in general. I think the most useful way to understand what work is work is the means by which energy is. I'm going to say here, I'm going to put this in quotes because you can quote me if you want, that energy is moved around. You can say transferred. That's fine. In Chapter 8, which will be upon us soon enough, that's another chapter all about energy. And in that chapter, we will pin down. Right now, we're really talking about work and kinetic energy. In Chapter 8, I don't think it's too much of a spoiler to tell you that we'll also start talking about some kinds of potential energy, two in particular, gravitational potential energy and spring or elastic potential energy. How does a spring, for example, I got one right here, and here's a spring. So when this spring is compressed, it's storing some energy, and then if I had something like this little cart compressed up against it, and then I released the cart, then the energy that was stored in the spring becomes the kinetic energy of the cart. And how does that magically happen? Well, work is that process. Work is the transfer of that energy. So here we would say the spring is doing work on the cart, that spring force. So what does work? Forces do work. What do? They transfer energy or move energy around. What we know right now is that the sum of all forces, if you know the net amount of force, then the net, or the sum total of all the work done by all the forces acting on something, that's equal to the change in its kinetic energy. That's what we're doing right now. So how about the work done by a gravitational force? So remember that here, for a constant force, work is equal to that force times the displacement that it goes through as a result of that force. And then also, if they happen not to be pointing in the same direction, times the cosine of the angle between them. And gravitational force is constant, nearly. That's not supposed to be any kind of crazy statement there. But, like if you're on the top of Mount Everest and then you're at the very bottom of the lowest valley on the Earth, the gravitational force is very slightly different. But for our purposes, we really are not interested in that. Our gravitational force, we use this 9.8 newtons per kilogram to quantify that, and the difference between the variation of the gravitational force at the surface of the Earth happens in this next decimal place that we're not keeping track of. I think it varies. You could look this up. I think maybe 9.78 to 9.81 is the variation that you see in various places around our planet. So 9.8 is the correct rounding of that to the nearest tenth for all of the Earth. Okay, so what about work done? And since this is constant, that means the work done by gravity is equal to the gravitational force, and then what should I put here? I could just put the d there, but the thing that matters, since the gravitational force is down, then the only direction that matters, if you think about this here, that it's only these multiplied together in the direction that they agree upon, and that cosine theta takes care of that. So the only thing that matters here is the change in height of something. So that would be times its delta y. And maybe that delta y is positive, and maybe, of course, the force of gravity will always be downward, maybe the delta y is negative. So what's going to happen, like what kind of work is this force going to do if this goes up here? Well, these two things are not in the same direction. They're really like 180 degrees apart, right? This is pointing down and this is pointing up. So if you think about that cosine of theta, cosine of 180, that's negative 1. And this is going to give us negative work, which makes sense because if something is going up, the gravitational force is pulling down on it. You think of like a ball that was thrown upward and is slowing down as it reaches its peak. What kind of work is gravity doing? It's doing negative work. It's taking energy, the kinetic energy, out of that ball. Here, in this case, if you just drop something, and the gravitational force is this way and it's moving this way, well, the kinetic energy of this is going to increase. That's going to give us, we're going to call that positive work. So when we write this, then depending on how you want to quantify this, there's different ways of dealing with this. I think probably we would want to put a negative sign there if we think of this as just being a number. And then that delta y, that could be positive or could be negative. If it's negative, if the delta y is, so we're using the convention here that up would be positive. So if the delta y is negative, if it went down, then this is negative, that's negative, that would give us the positive work. So, however you want to manage that, we just need to make sure that we get this right. Right? If something's going up, well then gravity, the force of gravity did negative work. If something's going down, then the down and the down agree with each other. That's positive work. That is all you need to know about work done by the gravitational force. Remember, it's a great idea to work through the videos. Like, for example, if you try, I think number 17 in the book is the first one you might try after this. If you're, do as much as you can, then look at the video and work back and forth with me as needed. Okay?